Hello students, now I am discussing about the unit ramp signal. This is one of the subclassification of basic signals. Okay, definition of unit ramp signal is it is denoted by R of t in continuous manner R of t, in discrete manner R of n, as we know that. So R of t, what is the answer here? At R of t, okay, t is greater than or equal to 0 at R of t is equal to t. Okay, at 0 t is less than 0. This is the continuous manner, and discrete manner R of n we are taking. As I said that the value of the alphabets are changed, right? Okay, the replacement of t with n. Okay, then what is the n value here? N is greater than or equal to 0 at n. Okay, n is less than 0 at 0. Okay, at continuous manner of unit ramp signal, at discrete manner of unit ramp signal. Now I am taking the examples of or graph for unit ramp signal. In the horizontal axis or x-axis we are taking at t. Then what is the unit ramp signal denoted? R of t. Okay, here positive values, here negative values, here some values. Okay, this is the positive axis and this is the negative axis. Then coming to definition formula, what is the value? T is greater than 0, greater than or equal to 0 at t, at R of t is equal to t, at t greater than or equal to 0, right? T is greater than or equal to 0 means from starting 0, right? From starting 0, okay, at t, t greater than or equal to 0, and increasing means we are taking 1, 2, 3 and so on, means at t, okay, the t is greater than or equal to 0. Okay, greater than means we are taking 1. Okay, at t greater than or equal to 0, greater than 1. So R of t value how much? 1 only. Okay, at t R of t is equal to 1, at t is equal to 2, R of t is equal to 2, at t is equal to 3, R of t is equal to 3, and so on. So the unit ramp will come like this. Okay, the unit ramp signal will come like this. Okay, this is the continuous unit ramp signal. Now I am explaining about the unit ramp signal in discrete manner. Okay, 0, 1, 2, 3, minus 1, minus 2 and minus 3. Okay, what is the R of n value at n greater than or equal to 0? N greater than or equal to 0, what is the R of n value? N only. Okay, then what is the R of n value at n greater than or equal to 0? N greater than 0 and greater than, what is the R of n value? R of n value how much? 1 means 1 only. Okay, then R of n value is greater than 2 means what is the R of n greater than or equal to 0, increasing by how much? 2, right? So R of n value how much? 2 only, like this. Okay, we are increasing the values means the n value also increases. Then the formula R of n is equal to 3 means n is greater than or equal to 3. Okay, so this is the graph for discrete unit ramp signal. Now I am saying about the relationship between unit step signal and unit ramp signal. Okay, u of t and r of t. What is the definition? I am rewriting the u of t formula here. At u of t, t is greater than or equal to 0, the u of t value is 1. At t less than 0, the u of t value is equal to 0. Okay, and again r of t value, what? At t greater than or equal to 0, at 0 t is less than 0. Okay, less than 0. So here taking integration part. Okay, integration part, u of t is equal to, now I am taking the positive values here, no need to take the negative values. Okay, so u of t dt from r of t. Okay, one thing we observe here, from 0 to n or t or infinity. Okay, at 0 to infinity, what is the value of u of t? 1, right? Okay, 1 into dt is equal to r of t. Okay, so here one thing, from minus infinity to plus infinity also we can take, means no problem. Okay, not an issue, because from minus infinity to infinity, what is the u of t value? 0, right? So 0 into d2 means 0. So what is the 1 into dt value? 1 into dt value, u of t is equal to d by dt of r of t. Okay, this is the relationship between u of t is equal to d by dt of r of t. Okay, the integral value here. Then now I am taking the relationship between, here the relationship between impulse and unit step function. This is also very important by using Laplace transform. Okay, so integration of del of t into dt is equal to u of t. So we can derive the relationship between unit step signal and unit ramp signal, means how much? Integral of u of t is equal to d by dt of rt, right? So double integration of, so the double integration of del of t into dt, because what is the value of del of t into dt? U of t, right? So we can tell that del of t into dt, u of t into dt. Okay, u of t into dt. Then integration will apply by using the relationship between the impulse function and unit ramp signal r of t. Okay, so here what is the value of u of t here? d square by dt square of r of t. Okay, d square by dt square of r of t, d square by dt square of r of t. So this is the answer of relationship between unit ramp signal and unit step signal. Okay, this is the relationship between unit step signal, the impulse signal and ramp signal. Then it will be derived by using, okay, unit step signal by using r of t or unit ramp signal. Okay, thank you.